This is the graph that I was going to look at. We have to take into consideration two things. The distance between here, like the bottom of this graph, and the x-axis, like 0 over here. Oh, the the x-axis over here. And the distance between over here, like at the end of this graph in regards to the y-axis and the start, like until over here. So the distance between like the end, the very left of this graph to the start of the graph over here, or shall we say like the middle end of this like curve, this distance represents the bond length. So that's that. And the distance between the x-axis over here and the y-axis of, or just the 0 over here, that's the y-axis. The distance between here and here in terms of the y-axis represents the bond energy, right? So you can kind of guess that if the bond length is shorter, which means that the middle part of this curve should be all the way over here, then that means that there should also be a greater like height of the curve, because the shorter the bond length, the greater the bond energy it is. And so the more further away it moves like this, that means that the bond length is very long, but that also means that the bond energy is also very weak. So it will be looking like this. So it will be further away from this graph, but it will be much more closer to the 0 line over here because the bond energy is lower. So in summary, in short, the graph between the potential energy and the internuclear distance just gives you information about the bond length and bond energy of a molecule.